Hello, everyone, and welcome to this past marathon on open source. We're excited you could join us today for Luis Beltran's session, Bringing AI to the Edge. This past marathon features back-to-back live webinars delivered by expert speakers from the press community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the recordings are available. My name is Fernando Cibaja. I'm a SQL Server Technical Advisor and past speaker. I will be moderating this session today. Before we start, I have just a couple of introductory slides. If you require technical assistance, please type your request into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions through the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions to Luis. You're able to zoom in the presentation content by using the zoom button located on the top of the presentation window. Please notice that there will be a short evaluation at the end of the session, which will pop up after this session ends in your web browser. Your feedback is really important for us, so please take a moment to complete this. Don't forget to visit pass.org and check out all the free educational resources available to past members. So this past marathon session is presented by Luis Beltran. Luis is a Microsoft MVP and an AI developer on Xamarin Technologies. And he's a professor at the Instituto Tecnológico de Celaya in Mexico. Luis is currently pursuing a PhD in engineering informatics at Thomas Para University in Slim, Czech Republic. He's passionate about sharing his knowledge and learning new things, which are his main motivation for every day. And without further ado, here is Luis with Bringing AI to the Edge.
Thank you very much for the introduction, Fernando. And well, hello everyone. Thank you also for joining my session at this past marathon. I hope that you have been enjoying the previous sessions. There was a lot of knowledge about Git, about Power BI, about SQL. So, well, we will finish this event with an artificial intelligence topic. This presentation is focused on development, also on cognitive services and Docker containers. So I hope that this is useful for you and also interesting. I'm pretty excited to participate in this event and share my experience with the topic. If you have any questions, feel free to ask, and at the end of the presentation, I will try to answer them. So please let me know your thoughts, okay? Well, I also hope that you obtain the skills and knowledge needed for implementing the Azure services running in on-premise scenarios. So let's get started. So the agenda here goes as follows. First of all, we will talk a bit about Azure Cognitive Services, what they are, what areas exist, and an example about some of these services. Then we will move to Docker containers, which play a key role in this topic. We will mention how they help us to bring our applications up and running everywhere. And the third topic is the container support in cognitive services. Of course, this is the main part of our presentation. We will talk a bit about the steps that you need to follow in order to have this on-premise on-premise AI running. Of course, there are some commands that you need to implement, some software, we will talk a bit about it. There are some requirements that you need also for the environment. We will mention them. And of course, there will be a demo. In this case, it will be a mobile application which retrieves the information after requesting the service, for instance, after submitting a picture, and then we will get information about this multimedia element. Finally, we will conclude the presentation with some useful links for you to implement the cognitive services on their containers. Okay, so let's start our session talking a bit about Azure Cognitive Services. What they are? Well, they are a collection of already deployed APIs, SDKs, and services available for building intelligent applications. The good part here is that you don't need to be a master or an expert in artificial intelligence or in data science, because at the end, it's just a request, an HTTP request to an endpoint. So it is very easy to add these cognitive features into your applications. So that means that we can develop applications which are able to see, to hear, to speak, to understand. Also, an important element here is that you can use any technology that you want. You can write applications in C#, in Java, in maybe PHP, because at the end, writing codes for HTTP requests is kind of agnostic, let's say. You don't need specific languages, okay? Of course, there are SDKs. There is Node.js SDK and there is a .NET SDK. And if you want to use another language, such as maybe Java or PHP, you can always request, make HTTP requests. Well, as you can see here, there are several categories for cognitive services. There is vision, there is speech, there is language, there is knowledge, and of course there is web search, which is not in the slide, but this is the Bing services, okay? And in each category, you have several services. For instance, in the vision category, you can submit an image, let's say a picture of a person, and the service will retrieve information about this picture, such as if the person is wearing glasses, an approximate age of the person, even if there is another element there, such as a mobile phone, that can be detected. Also, if there is an emotion in this person, if it's happy or sad or some others. If you submit an image with text, there is also the OCR, so it can detect the text, and also so it will draw some rectangles, or it will give you the coordinates where this text is located, and of course the text within the image. You can also use the speech service for submitting an audio file, and it will return the text that is contained in there. So this will be speech to text, but it is also possible the opposite, text to speech. And well, there are several other services that you can run, and you can easily implement the artificial intelligence in your application. So, well, talking a bit about one of these services, we have the text analytics, which basically you can perform sentiment analysis, extract key phrases, detect language, and also the topic detection. What do they mean? Well, for instance, in sentiment analysis, the API returns a numeric value between 0 and 1. A value which is close to 1 means that the text is positive or has a positive connotation. And if it's close to 0, it means that it is negative. Internally, I can say that well, this sentiment score is generated using classification techniques, and is available in some languages such as English, French, Portuguese, and Spanish. Key phrase extraction and topic detection are similar in the sense that you submit again a text, but this is mainly used for large amounts of text, paragraphs, or even full chapters. And the basic idea is to detect the topic or to identify key elements, key phrases that can sum up the whole text, right? So this is like a clustering of the information that is included there. And finally, the language detection. Well, it's quite obvious what it does. You submit a text, and then it will detect, okay, this text is in Spanish, or is in Japanese, or is in English, etc. It has support for 120 languages. Well, as I mentioned, the requests are made in HTTP. So you perform like a post operation. And as a result, you obtain a JSON element. I will show you in the demo. Well, if you go to the Azure Cognitive Services website, you can interact, you can play, let's say, with this. There is some buttons to test the services. In this case, you can write a text and you can analyze it, and you will retrieve some information about the language, the key phrases, or the sentiment. You can see here in a friendly environment, analyze text, but of course you can also obtain the JSON content, all right? That will be useful for us to create some models and then implement it in our application. But okay, if we talk a bit about development, okay, how can we implement or integrate these cognitive services in our applications? Well, the first step is to go to the Azure portal. So you just click on create a resource, select AI plus machine learning, and you will see that there are some categories there, but of course there are many more, which you can click on the see all, and you will view all of them. Okay, so in this case, when we select one of these services that are interesting for us, let's say text analytics, well, we will be required to fill in some information as usual, such as the name, the subscription, the location, the pricing tier, and the resource group. In the pricing tier, I can say that every service has a free tier, so it means that you can try the cognitive service without any dollar charged to you. Every cognitive service includes some, let's say, limits in the free tier. For instance, in text analytics, it means that every month you can request up to 5,000 text or transactions for free. And after 5,000, well, the service is, let's say, down. So you will not be able to make further requests until you either upgrade to a standard tier, which means that now you will be charged, or you can also wait until the next billing month. So it is up to you. And also it depends on the application that you are developing. After you create this resource in your Azure portal, you will have access to a panel. In this case, you need two elements which are important for implementing the cognitive services in our applications. The first one is the endpoint. Of course, this means where should I make or point all the requests. In this case, since I selected the West Europe, well, the endpoint goes there. And the second one is the key. We need a key. So the portal, so Azure can measure how many requests are doing from our applications, okay? And you can always regenerate your keys in case that they are compromised or some, okay? So basically, you need these two, and even in the container support, we will use these two. I will mention it when we are running the demo. Okay, so yeah, we can use the cognitive services for building real-world applications. For instance, we can develop an application in which the users ask for some directions with their voice by using the speech-to-text service. In this case, the audio is converted to text. We can also combine it with another service, such as Luis, which is a language understanding intelligence service. And then we can detect the intention of the user. Okay, the user wants the application to give him or her directions to some city or to some point of interest. So yeah, we can combine, we can use, we can even call other APIs. We can use the information and the data that is both sent and generated and combine it with another services, right? So the sky is the limit to what we can do with the cognitive services, right? So, well, this was a brief introduction to cognitive services. Now, what is a Docker container, or what is a container? Well, basically, normally we develop applications in our machine, and most of the time we have, or we might have, some problems when we take the code and run it in another computer or deploy it to the service. Either we are missing some resources, or there are some dependencies that the operative system, the target operative system doesn't have, or there are some components that are not present at the deploying time. So this is the physical part. A solution for this is to use virtual machines, because we can configure it the way we want. We can say, okay, we need these specific resources, such as the hard drive space or memory, like 2 gigabytes or 4 gigabytes. This is great because we can create an image of the virtual machine, and then we can have our app running. But still, there is a dependency in hardware. There is a limitation. So a solution for this is to implement containers. Basically, a container is a standard unit of software that packages the code, and this is the important thing, all its dependencies. So the application can run in a reliable state from one computing environment to another, because we are bringing everything that the application needs. Containers and virtual machines have a similar resource isolation and allocation benefits, but there is a difference. There is a difference because containers virtualize the operating system instead of virtualizing the hardware. And because of this, containers are more portable and efficient. Okay. So if we need a container image with 1 gigabyte or 2 gigabytes, we can add this, let's say, parameter or requirement when we are starting our container in another environment. Okay. And you can see in the slide that we have the application, we have several containers, and we have the kernel. And in the other case, in the virtual machine, we have the whole operative system. So yeah, This is one of the differences. Okay, and also, what else can I say? Well, containers are an abstraction of the app layer. So basically, you are packaging the code and dependencies together. Virtual machines, on the other hand, are the abstraction of the physical hardware. Okay, so one is operating system, and the second one is physical hardware. It is possible to run several virtual machines in the same machine. This is because of the hypervisor, Hyper-V, for instance. But as I mentioned earlier, every virtual machine includes a full copy of the operating system. So we also need a license, for instance. So that means that's another difference. The virtual machine is larger in size, even gigabytes, depending on the operating system. And the container is shorter, maybe in megabytes terms, because we are not virtualizing the operating system. Or maybe we have just a liked version of it. Okay. A Docker container, in this case, we are talking about now a specific technology. A Docker container image is like an executable package of software, which includes some dependencies needed to run an application, such as some code, there is the runtime, system tools, some system libraries, and maybe also third-party packages. Okay, container images become containers at runtime, and in the case of Docker containers, the images become containers when they run on some software called the Docker engine, which is available for both Linux and Windows-based applications. So this means that the containerized software will always run the same, regardless of the infrastructure. Okay. So yeah, we can have, for instance, a Windows a client, but running a Linux container, sorry, an application or a container which internally has a lightweight version of Linux, in this case, mobile Linux, and we can have several applications hosted there. So yeah, and another important thing is that we can have the same application, let's say application B, running in different images, but with different version. So you can see here version 1.7, version 1.9. So yeah, this is also possible because of testing, and well, this is quite normal in deploying environments. Okay. So well, this is the second topic. Now, let's talk about container support in Azure Cognitive Services, or what is the application of containers, or what are we talking about containers in an artificial intelligence topic? Well, maybe you figured out that every request that we make using the cognitive services is sent to the cloud, to Azure, to the Microsoft data centers. So you are sending a text, a piece of audio to the cloud. You require internet. But what if you can't upload this image or this text to the cloud? What if maybe you are working with sensitive data? You are, or your users are sending maybe the passport. They are taking a picture of the passport in order for the applications to detect text within the image. Maybe extract the password number or the country of origin of the person, the name, and so on. So you really don't want this image to be sent to the internet, even though you want to be analyzed by the artificial intelligence, and you want to extract this information. But you don't want, because of security reasons, or maybe for data compliance or privacy policies, you don't want this multimedia element to be sent to the cloud. So if you could analyze these images or text in a local on-premise environment, of course, your application will benefit from this reduced latency, bandwidth, and also security, increased security. So this is where the container support comes into play, because now the Azure Cognitive Services APIs are available as Docker container images. In this case, while Microsoft is now offering this support, you can download a container that provides the exact same functionality as the cloud-based services and run it on a local Linux-based server or device in your local network. So this means that the images, the text, the video, and other elements are processed directly in the container and never sent to the cloud. So it means that there is no latency. The security is also increased because your information is not being sent externally. But the server where you are implementing the container, yes, it does require a connection to Azure, but only this is only needed for billing. So to measure how much data are you sending or how many requests you are doing with to the endpoint with the key that you created before in the Azure portal. So you are sending just telemetry or data usage, but not the information itself, okay? This is important to understand. The pricing is the same. If you select the free tier, you will not be charged, even if you are using the local container or the cloud container, cloud request. It will be the same price. So basically, okay, the Azure Cognitive Services, with them you can develop applications, but of course you can also deploy it wherever you want. Okay. So that's the flexibility that the container support gives. And well, there are several advantages. Of course, you can process lots of data internally or locally. There is reduced latency, no constraints in network connection, because maybe, okay, you can send anything you want to the network. There is no privacy concerns, but maybe there is a limit in your network. The bandwidth, the internet bandwidth is not high. So you would prefer to have local server which process all the information. So yes, this is also useful for these scenarios. And well, this is because of the containers. The architecture is portable. Okay, you can take your application, your container, and deploy it wherever you want. And important, you always have the control over your data. It's your data. You can send a request to the cloud or to the local server. It's up to you. Well, now, not all the Azure Cognitive Services are available. There are some preview versions of some of them. For instance, in the computer vision service, you can send an image and it will recognize the text within this image. In computer vision, there are other services, but in this case, there is only one container. So yeah, you cannot describe the image, for instance. In the face service, you can send a picture and it will return some useful information about the age, about the face landmarks, about the emotion. Well, actually, we are showcasing this one in the demo. So we will talk a bit about in a few minutes. The LUIS service, as I mentioned earlier, this is used to detect information. In this case, for LUIS, you train a model. You can train it in the website, luis.ai, and you can implement it later to detect the intention of the user, some entities, and also what else? Yeah, basically the intention of the user in the text. If the user wants to book a hotel in Venice, okay, it will detect the intention, which is booking, the entity, which is Venice, the place, and also what the hotel. Okay, but in order to understand this, a LUIS model should be trained before with utterances or examples. Well, let me know in the comments if you have worked with any of these services. For text analytics, well, the functionality that we mentioned in the slides before, it is complete. You can extract the key phrase, you can make language detection, and also sentiment analysis. Actually, on GitHub, I have a demo about this one. Okay, what do you need to implement the Docker containers in your local scenarios or local environments? First of all, you need the Docker engine. This is a piece of software which you can download from the website. There are some specific requirements for Docker, some Docker engine, because you actually need Windows 10 Pro version, for instance. But there is a light version, which is called Docker Toolbox, which you can run in any other Windows, like Home or even Windows 7, Windows 8. Actually, I am using the Docker Toolbox, and you will see it in a few minutes. So the first requirement is the Docker engine. The second one is the cognitive service resource created on Azure portal. We already did that, so that's quite easy. Okay, this is the Docker Toolbox that I mentioned. You can see here the link. I can also share it on the chat if you want. But this is an important step. When you download and run the Docker Toolbox for the first time, you will have a Docker container image created with 1 core and 1 gigabyte in RAM. But all of the containers require at least 2 gigabytes to work. So you first need to stop the Docker machine, then remove it and create it with this VirtualBox memory of 2 gigabytes, and the CPU cores, it's up to you. You can use 1 or 2. Some services require 2, but most of them require only 1. Okay, and this default is the name of the image. Well, Docker Toolbox runs the default image, so you can rename it. I mean, you can use the default. So every time you run Docker Toolbox, it will run now with 2 gigabytes. Okay. Well, as I mentioned, the containers also have requirements in hardware, in the host that you are running them. Every one of them requires or has a minimum, needs 1 core, and at minimum 2 gigabytes. For the Vision one, which recognizes text, you actually need 8 gigabytes in memory. So yeah, this is for high processing, but all of them, the rest needs at least 2. There are some recommendations that, okay, at least 4 gigabytes, especially in production scenarios. So that's why this command that I mentioned is important. Otherwise, when you download the image and try to run it, if you are working with the default image, it will not be possible to run it. You will get an error message regarding the memory that you are assigning to the container. Okay, So that's why you need to upgrade it to 2. Okay, so let's go to the demo. There are some other commands. Okay, after you run the Docker toolbox or another Docker engine, you will first need to download the container image that you will want to test. And you can get the container image with the Docker pull command. Docker pull and then the address of the container image. Well, in the Microsoft website documentation, you can see the repository for each of them. You can add the latest parameter, of course, to get the most recent version. Okay, in this case, I am downloading the sentiment container image, and you will see the progress. And the size is in megabytes, as I mentioned before. So this is the first step to use the Docker pull command. And the second one is the Docker run. Docker run, and in this case, you are assigning the port that you will be running the application. Also the memory, 2 gigabytes, 4 gigabytes, the CPU cores. This is again the container image that you would like to run. You of course accept the EULA, and if you remember, we mentioned that there are 2 requirements: the endpoint and also the API key. So you are actually using them here, billing, the endpoint, and the API key. So yeah, that's quite easy, and I can show you right now here. Okay, in this case, I am running the face API, and you can see Docker run the ports. You are exposing the port 5000, and the application will use the port 5000. 2 gigabytes in memory, 1 CPU, and this is the address of the face container, the billing, and the API key. And after we are running this, we will see that the application is listening in this port. So I can open, in this case, the browser. Okay, also when we run the Docker image, you will get an IP address. Let me show you here, where it will be listening to. Here, the default machine IP is this one, which corresponds to the one that I am visiting here in the browser. Okay, and the port is 5000. So here we can see the API description. In this case, as I mentioned, I downloaded the face container. So in the face container, there are several functions. You can detect a face, and then also some information about the image. You can compare 2 faces to see if they look similar or not. You can create groups, like for instance, if you are developing an application for employees from different organizations or from different departments, you can assign them to a group. You can even store the face and also associate an ID for further identification or verification. Okay, so this is basically the API description. And there are some other functions there, like obtaining the list of faces inside a group or from a specific ID. So, well, it is quite descriptive, everything here, because you can see now the parameters for this request, and you can even test it. Here, I can try. So let's say I want to know the emotion, and also to see if there are glasses inside a picture. I can choose one here. Again, you can see that this is in local. This is my machine actually. So let's try this one and execute. And here you can see the JSON response, which assigns a face ID. There is a face rectangle, which means in which coordinates this a face was identified. And then, okay, some glasses were identified, and also the emotion of this face is neutral. I can show you again the image. Maybe I was very fast. Yep, this one. Okay, that one. And so yeah, you can even test it here. But of course, you can also deploy or develop an application for testing this one. In this case, well, okay, let's try the camera again. So this is me. Okay, give me a second because I forgot to turn on the camera. This is the emulator, Android emulator. Okay, let's try again. Yep. Well, since I am sharing the webcam on the application, you cannot see it here. Okay, so well, maybe you have a problem here. Since we are using the webcam in the chat, or maybe I can, okay, I will try to turn it off from the application. Let me see if that works. Yes, okay, so let's try again. Let's test it. I will be back here. Yeah. So it detected that, okay, it's a male, it's smiling, and the emotion is happiness. And well, we can try with maybe other application, other cases. Let's try this one. As you can see, I tested several times. Yeah. And in this case, no glasses were detected in the image, and the emotion was okay, more or less happy. And the code, maybe you want to see some of it. Well, as it was mentioned in the presentation, I mostly work with Xamarin. So in this case, I developed a mobile application. There is the code is on my GitHub. I also have the link of it in the next slide. So here you can see that the requests are sent to this address, which is the one that we mentioned before. This is the local endpoint. The service is face version 1 detect. I obtained this from the documentation here. Yeah, face version 1 detect. And the parameters are this one. Okay. It is important to test it from this page, because you can see when you are creating the request, you can see the request URL. So yeah, it was quite easy to identify the parameters. So this is basically the request that I'm making. Okay, I am identifying if the person is smiling, there are glasses, the emotion, all right? And okay, the JSON that is generated as a response has more or less this structure. Okay, I added other properties, so that's why there is a smile here. In the face attributes section, gender, glasses, emotion. Yeah. For emotion, you can identify kind of dictionary. There is a key, the name of the emotion, and there is a value. Values go from 0 to 1. In this case, well, it was quite neutral, the face that I submit. But in the application, you can see it's 0.56. Okay. So these are the models for the response. And well, for the rest, okay, this is the face service. I am just using the well-known HTTP client. I am sending the request to the local endpoint, which you already saw. And yeah, this is just preparation. We are sending a stream. This is the image, and we are serializing the information. Okay, but in the end, every request is sent to this container that is running here. Yeah, I can, of course, demonstrate that. If I close this, well, yeah, it is shutting down. You will see that the service will no longer work. Okay, we will, yeah, I will use this. And now it's not detecting because it's not running. Okay. So, yeah, I think this is the most important part of this code. The rest is just the views, the view models, the functionality. But this changes depending on the technology that you are using. So, okay, we already went through this. In this one, I was just demonstrating the sentiment for text analytics, but the demo, well, of course, it's different. Okay, yes, this is the the link for the demo. I will share it on the chat, of course. I just need to mention something very important. The face and vision containers require private access. So it means that they are not public. For this, you need to actually log in to run these containers. You need a username and a password with this command, docker login, container preview, and so on. This is the link, the URL. Using the username and password. You obtain the username and password by requesting access to it. I think I have the website here. Just give me a second. Yeah. If you go to the documentation, you will see that yes, you need to request access to this container registry. It is just a request form, some information about you. What are you? Why do you need access? I mean, what kind of application you want to build with it? And if your submission is accepted, you are given a username and a password that you can use for your requests. Okay. But yes, you need the access. Then the rest is the same. You use the Docker pull and the Docker run again. So in my part, from me, that's all. I will just share some resources. The documentation is the first place to go to understand about container support of the cognitive services. There is a nice video about them. Of course, there is also cognitive services and Docker images. You can have the full repository list, except the ones that need the access. On GitHub, there are some samples from the Azure team. And yeah, as I said, well, in the slides, you can find later these links. If you have any question, please let me know in the chat.
So we only have one question so far. So to all the participants, if you want to ask more questions, you can do so by using the questions pane. The one question we have is related specifically to containers. By Radu Popa. It says, do containers allow direct access to physical resources? For example, CUDA GPU.
Okay, yeah, I'm not an expert in containers, to be honest. I'm more on the artificial intelligence part. So yeah, well, you can send me an email if you want, and I can check it later. I will share my email on the chat. To be honest, yeah, I'm not expert on containers. If someone knows, can help us on that. But I think yes, because since the Docker images from the containers detect that, okay, you are running under 2 GB or 1 GB memory size for this image, maybe yes, it is possible. But
okay, we have another question.
Yes.
Brian, what are the costs of the service?
Yes, nice question. The price is the same as the cognitive service itself. What I mean is that there is no extra charge if you are running on local containers. For instance, I think I show it in a previous slide. If okay, you can run, for instance, the Face API for free, either on the cloud or in the local container. I can show you in Portal the one that I'm using, and it's for free. So it's the same. Every cognitive service has their free tier and also their pricing schemas. So it depends also on the container. I am using this one, Face Local Container, which has an endpoint in West Europe. Yep, and the pricing is free for this one. There is also an important element here. As you can see in my project, I don't have any key or any reference to the West Europe endpoint in the local application, because everything is assigned here in the container. Right? So the container is communicating to the Azure portal, but only for data usage. Your application is not sending the data to the cloud. Okay, that's important to understand. Is
okay,
there
so we don't have any other questions. So I guess we can wrap up the session. Thanks a lot, Luis, and thanks everyone for coming. And thank you for attending.
Yeah, thank you very much, and have a nice evening there. And feel free to reach me out if you have any other questions. Goodbye.
Bye, everyone. Thank you.